Good morning, everyone. Hope all is well. Hope everyone's doing all right. All right. So, last class we did some reviewing out of chapter 7. So, we're going to not close out, but begin chapter 8. And make sure I got it up. Okay. And so these notes are a little different. I went to go write in one class and I had them on a screen, and they all agreed that it was easier to just look at the page of notes that I had. So I'm going to share this screen and just magnify it. So this is 8.1, distribution of the sample mean. May do 8.2 today, may not. But in chapter 8, it's only 2 sections, 8.1 and 8.2. So 8.1, distribution of the sample mean. The sampling distribution of a statistic is a probability distribution for all possible values of a statistic computed by a sample size of n. And just like before, the first section is always going to be a lot of words, establishing the foundation, then we'll get into the calculation. In the next statement, the sampling distribution of the sample mean x bar is a probability distribution of all possible values of the random variable x bar computed from the sample size n from a population with mean mu, standard deviation, sigma. So those are same symbols from before. Mean is mu, standard deviation is sigma. Right on the first sentence. Good morning, sir. All right, suppose that a simple random sample size n is drawn from population with mean mu, standard deviation sigma. Sampling distribution of x bar has the mean. Notice the mean is going to be the same thing as the population mean. Then the standard deviation of a sample distribution is going to be that sigma divided by the square root of our sample size. And as always, once we put numbers on it, we'll be able to piece these things together a little better. All right, scrolling up. The standard deviation of the sampling distribution of X bar is called the standard error of the mean. Then it says if a random variable X is normally distributed, the sampling distribution of a sample mean X bar is normally distributed. So you see I wrote there, that means we can use the z-scores. All right, and do I still copying this? Can we go to the next page? All right. Oh, so I'm still copying. Okay, cool. Yes, this is 8.1. This is 8.1. Mm-hmm. All right, anybody else before we go to the next page? Very good. Let's look at the first example. So it says the IQ, calling X of humans, is approximately normally distributed with the mean of 100, standard deviation of 15. Compute the probability that a simple sample of size n equal to 10 results in a sample mean greater than 110. So the black is the actual problem. The red is when we start getting into solving it. So what you guys write before I go there? All right, so once again, the IQ of humans is approximately normally distributed with the mean of 100, standard deviation of 15. Compute the probability that the simple random sample of size n is equal to 10. Results in a sample mean greater than 110. So you remember going back to your z-scores and how we did things in chapter 7, less than, greater than, between are three scenarios, same three scenarios that can occur here. So we're looking at the possibility of the results of the sample mean being greater than 110. So whenever, when you pick your sample, what's the chances that the mean of that sample would be greater than 110. So gather all of your given information first. They gave us the mean is 100, standard deviation is 15, sample size is 10, and X bar is going to be what we are doing our comparison to. We want to know if it's greater than 110. So that's our X bar. So now, according to what we did, or what we established in the last page, the mean of our sampling distribution is going to be the same as your mean of your population. So that's going to be 100. That's always going to be the case. If it's normally distributed, then this is going to be the case. All right. Then to calculate the standard deviation of your sampling distribution, you take your population standard deviation, take the square root of your sample size. So that's 15 over the square root of 10, 4.743. So before we go any further, is everybody okay with the given information and then how we establish the mean and the standard deviation of our sampling distribution? All right, scrolling up some. So now we can find our z-score. Very similar to how our formula was before. Got a data value, which in this case is going to be X bar minus the mean of your sampling distribution over the standard deviation of your sampling distribution. And we got 2.11. Then you go to the z-score chart like you would any other time. So same process as what we did last chapter. Went to the z-score chart. And when you go there, it should reflect 0.9826. Yeah, it depends on what they're asking of you now. If you're talking about rounding here for your standard deviation of your sampling distribution, they may tell you to round 3 or 4 decimal places. Just make sure you pay attention to the directions. But your z-score will always be 2 decimal places. Z-score will always be 2 decimal places. Yep. So watch Math Lab. They'll let you know what they want from you. All right. So don't forget the chart always gives you less than, but we want it greater than. So we have to subtract this value from 1. And so our answer is going to be 0.0174. And don't forget, I'll go back down, but we're talking about greater than. We want it greater than. When you're talking about chart, getting the chart value, yeah, we use the z-score chart. Yep. When you say go to z-score chart, that's what we're talking about. Yep. Then it says the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is 0.0174. So it's just putting a conclusion statement, putting it all together. All right, can I go to the next page? Anybody still copying? Anybody? Everybody good? Everybody good? All right. All right, so here we have the central limit theorem. It says regardless of the shape of the underlying population, the sampling distribution of X bar becomes approximately normal as the sample size N increases. So if the population is, let's say, skewed right, um, if you take a large enough sample size, your large enough sample size can be considered approximately normal. So if the distribution of the population is unknown or not normal, then the distribution of the sample mean is approximately normal, provided that the sample size is greater than or equal to 30. So 30 is going to be our matching number. And once again, this distribution being approximately normal is key because that allows us to use the z-scores and z-scores charts. If it's not approximately normal, then we would not be able to do so. So, we're looking for ways to be able to lean on the z-score chart. Scrolling up. Am I still holding on to that last sentence? All right. So let's look at this problem here. The mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. The obstetrician obtains a random sample of 35 low-income patients and determines their mean weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? I'll give you a chance to write that down. Okay, I'll start the problem on the next page. So, give you a chance to finish copying. Anybody still copying the problem before we go to the next page? Okay, not a problem. Take your time. Cool. Thank you. Thank you. Anybody else before I go to the next page? So I'll read it one more time. So the mean weight gain during pregnancy is 30 pounds with the standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. So remember, we need to be normally distributed. An obstetrician obtains a random sample of 35 low-income patients and determines a mean weight gain during pregnancy is 36.2. Does this result in suggest anything unusual? Now, this goes back to what we're just saying here, wherein the central limit theorem says that even if our population is not normally distributed, like in this case, it's skewed right, as long as we have a population size greater than or equal to 30, then we can assume approximately that it'll be normally distributed. And that's what we have here. We have 35. Okay. All right, so hold on one second. Let me check something real quick before we get into that. Yep, okay. All right, so I've given information, wrote that over here in this box. So our mean was 30, standard deviation 12.9. Our sample size is 35, and what we're doing our comparison to X bar, 36.2. All right, so the mean of our sampling distribution is going to be the population mean, which is 30. So no calculation there, just understanding the process. And then the standard deviation of a sampling distribution is going to be standard deviation over the square root of n, 12.9 over the square root of 35, which is 2.180498. All right. So then you go to your z-score, plug in the values accordingly. 36.2 minus 30 over 2.180498. Remember, when you're doing your calculation, it's always good to go 4 or 5, maybe even 6 decimal places, so you get the most accurate value possible. So we got 2.84. Now, your z-scores, you always round to 2 decimal places. Just reminding you of that again. Go to your chart. When you go to the chart, they give you 0.9977, which always represents less than. Whenever you go to the chart value you get will be less than. If I scroll up too far, let me know. Okay, so that first statement right there says, since we want to know how unusual this is, then we want to know the chance of it being greater than. So we're going to find greater than. by subtracting that 0.9977 from 1 gives us 0.0023. Scrolling up some. And so this is unusual because the probability is less than 5%, which is 0.05. And we talked about that before back in, I think, chapter 3, where in our unusual meter, our bar basing something or determining whether something is going to be unusual or not will be 5%, which is 0.05 in decimal. If you want to know greater than, you subtract the chart value from 1, right? The chart value will always, the value that you pull from the chart will always be less than. So if you want to know greater than, you have to subtract that chart value from 1. Yep. Chart value always represent the amount of information that's less than. Oh, no problem. No problem. I think that's it for this page. Yep. All right. So make sure when you go about doing these problems, follow, the way I set it up. If you do it the way I set it up, then you should be able to flow with what they're asking of you. Write down your given pieces of information, use your symbolism properly, then plug it into your z-score formula, go to the z-score chart, and get your values accordingly. Also establish what your sampling distribution and the mean of and standard deviation of your sampling distribution. Anybody still on this page? All right, so we can go to the next page. Everybody okay? All right. Hold on 1 second. Let me see if that was it for 8-1. Okay, so that was the last. They only had those 2 examples for 8-1. Let's see, do we want to jump into 8-2 today? Let me see something real quick. While I'm checking on this, anybody see the Oscars last night? Anybody think that slap was fake at first? Yeah, I found out it was real. I thought it was staged at first. I thought, Will and Jada, not Jada, Will and Chris was doing the thing, but after further examination, yeah, that slap was real. Yeah. I didn't expect it either. But see, social media, they blow up over everything. You know what I mean? So I'm just like, I couldn't imagine that being real, but yeah, that was tough.
I thought it was fake too, and then I found the uncensored version of what Will
Right.
Smith was screaming at him. So I was like, okay, this is definitely not fake.
Yeah, it was tough, and I understand Will's position, but I think he could have handled it a little better than that.
Just a tad better, you know.
Just a little bit better, right? Oh man, yeah, it was funny. It was funny. It was funny and uncomfortable at the same time, you know. Yeah. I mean, because if you think about it, it could have just been handled verbally. If you wanted to walk up there, then to walk up there, but you could have just said, "Hey, man, my wife got a condition. You out of pocket." Yeah, but that was a tough slap. Um, let's see. What am I looking for? What am I looking for? Yeah, man. And it's crazy because he got all of these self-reflecting videos and all the stuff like that. Now you got to look at those a little different. All the positivity videos he got going on. But I understand he's been under a lot of heat lately. So, everybody had a breaking point. Yeah, he did. And see, so my whole thing is, let's say, The Rock has done Saturday Night Live and stuff like that. What if The Rock was up there doing a little thing and said something, not knowing her condition? Would he have slapped The Rock? You know, would he have slapped Steve Harvey? Would he have slapped, just, I think he did. He did what he knew he could get away with. So let's see. So we did 8-1. Got 1, 2. Let's see what's next. What's the next class? Trying to map this thing out, y'all. So we got 8-1, 8-2. I guess 8-2 is short, and then that we can go ahead and knock it out. I was trying to map out the rest of the course real quick. We can go ahead and knock out 8-2 because that's right. Because next class there will not be any class. I don't know if I told you guys I got to go out of town, so I guess we can go ahead and knock out 8-2. Relatively short as well. So let's go ahead and do that. So it's very similar to, yep, no class Wednesday. I'm going to send the email out to remind you guys and just to make sure that, if somebody's not here, they'll get that same information. So yeah, look for that. I'll probably send it out today. But yeah, no class Wednesday. So if I had even thought about that, I probably wouldn't have going through stuff, just went ahead and did 8-2. But 8-2 is distribution of the sample proportion. So suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion is given by p hat is x over n. And we talked about that. No, you know what? That was my other class. No, we haven't done that in this class yet, I don't believe. So p hat sampling proportion is going to be that characteristic over the number of our sample size. And it says where x is the number of individuals in the sample with the specified characteristic. Yep. Yeah, time flies when you're having fun, I can scroll up a little. And then the sample proportion is a statistic that estimates the population proportion. All right, we scroll up. Down here, just establishing our symbolism. Population proportion is always P for us, but then P hat is our sample proportion. That's it for that page. Can we go to the next one? Anybody holding on to it? Oh, somebody said something. Oh, my bad, my bad. All right. Anybody else before we go? Okay. All right. So computing a sample proportion. So this is not a full problem. Just make sure we understand how we would get p hat. So the Harris poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, 552 indicated that they plan to work on vacation. Find the sample proportion, in other words, p hat, of individuals surveyed who plan to work while on summer vacation. All right, so we want to find the sample proportion. Individuals surveyed who plan to work while on some vacation. So N is 1,200, that's the number of people surveyed. X is 552, that's the number of people who plan to work on summer vacation, out of that sample of 1,200. And so P hat is just going to be X over N, that's 552 over 1,200. Just 0.46, I probably did 0.46. Let me see, do it go 2 decimal places? Okay, yeah, 0.46, even, okay. Yeah. So I got a statement under there, but just want to make sure everybody's done with the actual problem. All right, good to scroll up. And so basically that just says that the Harris poll estimates that 0.46, or in other words, 46% of the adult Americans who vacation during the summer plan to work while on vacation. So it's considered an estimate because you're using the sample as a reference, to what the population would do. So remember, that's your sampling proportion. All right, anybody still copying? All right, we good, 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 good. Okay. So sampling distribution of p hat. For a simple random sample of size n with a population proportion of p, the shape of the sampling distribution of p hat is approximately normal provided. And once again, approximately normal is important because we can use our z-scores. So provided that when you multiply sample size times p times 1 minus p is greater than or equal to 10. So if it fits that condition, it's approximately normal. And if this is the case, then the mean of your sampling distribution is going to be considered p. And then we'll calculate the standard deviation of the sampling distribution of p hat by doing the square root of p times 1 minus p over n. So if this condition is met, n times p times 1 minus p, then if that's greater than or equal to 10, then our mean is going to be p, whatever our population is, and then this standard deviation is going to be square root of p times 1 minus p over n. All right, scrolling up some. If I scroll up too far, let me know. Anybody still doing standard deviation? Oh, that's all it is right there. See if I can. All right, so according to the National Center of Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you conclude? So I'll give you a chance to write that down. All right, anybody holding on? Still copying? I can go to the next page. Everybody good? Just want to make sure. Okay, so I'm gonna read it one more time. Somebody said something in the chat. All right, cool. Hold on. Is that a yes, you're still copying, or yes, you're good? I'll just read it one more time while we make that clarification. So according to the National Center of Health Statistics, 15% of all Americans have hearing trouble. Any random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? Okay, cool. All right, so first thing we need to do is establish, is it approximately normal? That's what we're doing in the red. So N is 120, that's a sample size. P is 15%, 0.15, that's the population proportion. So we do 120 times 0.15 times 1 minus 0.15. And we have to see if that calculation is greater than or equal to 10. And we see that that's equal to 15.3, which is greater than 10. And so since 15.3 is greater than or equal to 10, the sampling distribution is approximately normal. And that means z-scores can be used. And remember, that's why we're doing that, because they've done research and all the stuff like that. And so they're saying that if this condition is met, that means that the sampling distribution is approximately normal. And that means we can lean on the z-score chart in the z-score process. All right, so that allows us to go into A. So P hat is 12%, which is 0.12. And now we're just looking at A. B is going to be set up a little different, but P hat is 0.12. And then the population proportion is the same thing as the mean of our sample proportion, which is 0.15. And then to find the standard deviation, do the square root of P times 1 minus P over N. I made a mistake and put that, that's an error. I have the made a mistake and put a square root over N. I tried to blot it out, but I don't know why I didn't do whiteout. I don't know why I didn't do that, but anyway. So yep, so it's the square root of 0.15 times 1 minus 0.15 over 120. That gives me 0.032596. All right, then z-scores, the way we'll set it up is this way. As P hat minus the mean P hat over the standard deviation of our P hat is 0.12 minus 0.15 over 0.032596. And that will give us negative 0.92 as a z-score. All right, so once you have your z-score, you go to your z-score chart. And the chart would yield the value of 0.1788. Remember, the chart always yields the less than, the proportion that's less than. All right. So since the question asks at most, this means that we want less than. So when you say at most, you say at the most is this, and then you want everything else under it. So that's less than. If it says at least, then you're saying at least this value, but everything greater than it. So that will be greater than. But see, we're talking about at most. So at the most, this value, and everything else under that. So that means less than. So the chart value is going to be our answer. And so the probability that a random sample of 120 Americans result in at most 12% having hearing trouble is 0.1788. All right, questions, any questions? Anybody still copying this page? All right, going to the next page. All right, so this is B. All right, so let me remind myself of what B was real quick. So suppose that a random sample of 120 Americans who regularly listen to music using headphones, having 26 of them having, okay, gotcha. All right, so this, now let me go back and show you guys the difference in the two problems. So we go back to A and B. So A gave us P hat and 12%. B didn't give us the percentage or the proportion. It gave us the sample size and the characteristics. So we're gonna have to calculate P hat. So A gave us the percentage, which was P hat, and B, we're gonna have to calculate that first. So that's why we did this first. X is 26. I should have put N as 120. So X over N is 26 over 120 for P hat, which gives us the sampling proportion of 0.217. Mean and standard deviation stays the same. We didn't change the problem. We just changed the sampling proportion. So the mean and standard deviation is the same from part A. And then we find our z-score accordingly, 0.217 minus 0.15 or 0.032596, which is 2.06. All right, z-score chart. Go to the z-score chart with 2.06. That will give you a chart value of 0.9803. Once again, that represents less than. And then since the question asks what might you conclude, we should explore greater than to see how unusual this occurrence is. So as before, greater than is 1 minus your chart value, which is 0.9803. So that'll give us 0.0197. Now hold on to the z-score formula. So once again, we have a proportion that's less than 5%. So this means it is an unusual occurrence. right. Oh, just the results obtained are unusual. Okay, let's do that. Okay. Give you a chance to finish that up. All right, can we go to the next page? Finish off the problem. Everybody good? All right, last thing. Since it's unusual, we could make one of two conclusions. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15, and we just so happen to randomly select a higher proportion that have hearing trouble, or the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 0.15. And so that second conclusion is more reasonable. So those who normally use headphones are more prone to have hearing trouble. All right, questions. That's it for that. You guys a chance to finish writing. Yep, that's all of 8.2. 8.1 and 8.2 are very similar in practices. Um, you just have to establish what your mean and your standard deviations are in comparison to your information given. Then convert it to a z-score, go to a z-score chart, and then make sure you interpret the problem accordingly. Yep. That's it for 8.1 and 8.2. Okay. So next class, which will not be Wednesday, it will be Monday. So you have a whole week to see if you have any questions about anything, see if any questions are generated, possibly even get caught up if you're a little bit behind. Chapter 7 was 2 sections, chapter 8 was 2 sections. And so, someone said something in the chat. Well, there's one attempt on the final exam, proctored, because the final exam has to be proctored. So there's one attempt on the final exam proctored. And then I will give you the opportunity for makeup. The makeup will be at 75%, similar to what we did with the chapter 5-6 test, in which we did that 85%, but your final exam will be at 75%. Yep. And you get 2 hours to do the final exam, 2-hour block, and we'll schedule that out and everything. And if you're somebody who has accommodations, then you will email me individually, and we'll set it up so that you can take it in the testing center. But you wouldn't do that through me if you need more than the 2 hours. All right, is everybody good on 8.1, 8.2 before I go to something else? All right. So Pull up. So we did, if this stuff will come up for me. So we're gonna have to do this second test the same way we did the third test, where we did a proctored and do a proctored one, and then I'll give you the opportunity for a makeup as well. Just because we hadn't done any, we only done one proctored test, so we had to do this chapter 7 test, chapter 7, chapter 8 test the same way. So when we look at scheduling that out, so today is the 28th, looking at the 30th, and 4, and this should be 4, 6. Yep. So we did chapter 8 today. So no class here. So we're looking to review on next Monday. So we're looking to do a proctor test on this stuff. No, at the earliest next Wednesday. Now, if there are so many questions here on Monday that it tells us that we're not ready for it on Wednesday, then that's fine. But if only 1 or 2 questions occur on Monday, then I mean, what's stopping us from taking the test on Wednesday? So Monday will dictate whether we do the proctor test here or push it back to the following Monday. It doesn't bother me either way, but I would need input from you guys, So take this week. Once again, no class here. We're gonna most definitely be reviewing on next Monday. So that will be your opportunity to ask whatever questions you want. Not gonna bring about any new material. Then we'll look to do that proctor test on Wednesday, unless I get information from you guys that, it wouldn't be a good move. Let's see. Yep, that'll be on test 4. That'll be test 4, so that'll be on chapters 7 and 8. So those four chapters. I mean, 4 sections. Those 4 sections. 7-1, 7-2, 8-1, 8-2. Okay. So questions on what I said there? Like I said, I don't mind pushing the test to here, but I will need some info from you guys, on that. All right. All right. So we'll have that discussion on next Monday. All right. So questions before we close out. We still score 85 on the test review. Yep, I can still honor that as far as the test review. All right. Anything else? Anybody else? Let's see. Yep. Everybody good? All right. Well, you guys have a good one. Be safe. I'll see you in a week. Y'all take care.